In this video, I'll work through some sample problems involving rules for counting. So all of these problems involve this club that has 17 members, 6 of whom are male, 10 of whom are female, and 1 of whom is non-binary. And we want to know how we can elect a president, a vice president, and a secretary under certain conditions. So for this first problem, we're told that the president has to be male. And so what we're going to use here is the rule of products. The rule of products says that if you can construct the thing that you're trying to count, in this case, the results of the election, in stages, in steps, where you know how many choices there are at each step, then what you can do is multiply those numbers of choices together to get the total count. So in this case, we've got 3 choices to make. We've got to figure out who's the president, we've got to figure out who's the vice president, and we've got to figure out who's the secretary. So if we know how many choices we have for the president, we know how many choices we have for the vice president, and we know how many choices we have for the secretary, we can take those numbers and multiply them together, and that will give us the total of what we're looking for. Now, the only restriction is that the president has to be male. So let's make that choice first. We know that we have 6 males, so we have 6 choices for who the president could be. Now, how many choices do we have left for the vice president? Well, we've used 1 of our 17 members. There's no restrictions on who that vice president could be, so we have all 16 remaining members available for that vice president. And now we also have then 15 members left for the secretary. So the total here is going to be 6 times 16 times 15, and that works out to be 1,440. So that's our final answer to this one. So for the next one, we have a slightly more complicated condition. This time we want to know how many ways we can elect the president, vice president, and secretary if at least one of the officers is male. Now we have to think a little bit more carefully. If we go through this in the naive way of just saying, hey, I just have to figure out how many presidents I can have, how many vice presidents I can have, and how many secretaries I can have, we're going to run into a problem. Because when we think about our first choice, we say to ourselves, well, how many choices do I have for the president? Well, the president doesn't have to be male. I just know that one of the officers has to be male. So maybe I still have all 17 choices available for that president. And again, the vice president doesn't have to be male. They can't be the same person as the vice president, so I have 16 choices left. But now what about the secretary? Well, if I've chosen a male at one of the previous steps, then I again have all the remaining choices left. But if I haven't chosen a male yet, then I have to choose one of the remaining males. And so the number of choices I have here is unclear because it would depend on how many choices, or the way that the choices that I've already made, it would depend on how those choices went. So this isn't really going to be a way that we can approach this problem. Another way we could think about this is to think about breaking this up into several cases. Well, what if the president is the officer who's male? Well, then, again, the vice president could also be male, the secretary could also be male, and those cases would overlap in a lot of complicated ways. So instead, what we're going to do is solve the complementary problem. And the complementary problem is the problem where we count the opposite of what we want. In this case, the opposite of at least one officer being male is no officers are male. And that's going to be relatively easy to count. So if we think about the president, we think about the vice president, and we think about the secretary, if we're not allowed to choose any males at all, well, we have 17 total people, 6 of them are male. That means we have 11 non-males to choose to be the president. And then the vice president can be any 10 of the remaining non-males. And then the secretary can be any 9 of the remaining non-males. 11 times 10 times 9, that's 990. But now 990 is not the answer to the question. 990 is all the things that I didn't want to count. So I've got to subtract that from the total. The total results, where I have no restrictions, would be 17 choices for the president, 16 choices for the vice president, and 15 choices for the president. That's the situation where I have no restrictions at all for how the election could go. And that works out to be 4,080. So the actual solution to the problem that I wanted to solve in the first place, where we have at least one officer being male, is the 4,080 total results minus the 990 results where we don't elect any males. And this gives us a total of 3,090 elections where at least one of the officers is male. Now for our last example, we're looking to figure out how many ways we can elect a president, vice president, and secretary if the president or the vice president is non-binary. In this case, we have 2 cases, 2 separate ways that this could happen. The president could be non-binary, or the vice president could be non-binary. Now, whenever we have these cases, we want to worry about whether or not those cases overlap. Because if we add up the number of ways that the president could be non-binary, together with the ways that the vice president could be non-binary, well, could both of those things happen? If they could both happen, then those two cases overlap. And we have a situation where we have to subtract the stuff in the middle that we've counted twice. But in this case, because there's only one non-binary person in this club, it can't be that both the president and the vice president are non-binary. And so in this case, there's no overlap. But it's always something that you want to worry about when you want to use the rule of sums. So, since the president is non-binary, there's only one choice for the president, but we've got 16 choices for the vice president and 15 choices for the secretary. And that's going to give us 240 possibilities in that case. Now, with the vice president being non-binary, there's no rule that says that we have to choose the president first. So let's go ahead and choose the vice president first. And again, we know that that's going to be our one non-binary person, and then 16 choices for the vice president, for the president, and then 15 choices for the secretary. So again, we get 240. And then because both of those are complete election results, where the vice president or the president turned out to be non-binary, we add those together using our rule of sums, and we get 480.